environment. I don't like this environment. I told you. Okay. This background. Sorry. Entonces, plus 18. Plus 18. Minus 3 times x, minus 3x. Minus 3 times minus 6, plus 18. Divided by x minus 6, less than 0. Okay, now we combine. Like that, why not? Entonces, negative 2x plus 18 over x minus 6. We can do some more. Yeah, of course we can. We can because I can see at least 2 or negative 2. I don't know if it's most convenient factorization and the top part 2 or negative 2. I suppose que 2. The 2 factor out 2. We have minus x plus 9 over x minus 6. And it's my final answer. No. I can do some more. Something more. For example, you know very well that any factor that is possible is completely deleted, totally deleted. So these two is completely irrelevant. Yes or no? However, I feel more comfortable if you delete this. Actually, delete. Do you understand why it's possible to delete? And the inequality doesn't affect by the 2. Suppose another way to see, if you divide by 2 both sides, 2 divided by 2 is 1, and 1 is invisible, and 0 divided by 2 is 0. Entonces, now I write the top part like that, 9 minus x over x minus 6, less than 0. And this is the inequality that I need to solve it now. Okay, and not the horrible original. Okay, nobody understand very well. Any questions so far? Any questions? Do you understand the algebra? Okay. After that, critical value. Critical value is the 0. 0 of the top and 0 of the bottom. It's obvious that the critical value is 9 and 6. And we're using this critical value to make a partition of the all real number line. This is my all real number line. And we have, suppose que 0 is here, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the partition. We split our all real number line using 2 partitions. Therefore, we have 3 intervals. And you select completely arbitrary testing point, maybe 5, maybe 7, and maybe 10. Or 0, or 1, or 8, or 11. It doesn't matter what testing point you select, always inside each interval. And let's do in the table. The table contains 5, 7, and 10. It's our testing. The factor involved in the problem is 9 minus x, the top part, bottom part, x minus 6, and total. And you evaluate. When you evaluate 5 here, it's obvious it's positive. When you evaluate 5 here, it's obvious it's negative. And positive and negative together is negative. 7 is positive. 7 is positive. Because 7 minus 6 is 1. So it's positive. 10 is negative. 10 is positive. It's negative. But we come back at the beginning. Look, this sign is less than 0. And this is equivalent, synonym to say negative. So the true guys is this. And this. So 5 pass the test, 10 pass the test, and 7 no. Now the solution is this interval. and this interval. Always the interval is from the critical value, no? Okay, critical value is the boundary que separate the interval. Okay, so what is my final answer? My final answer is from negative infinity to 6, not including 6, of course, not including anything, any endpoint, because there's no equal here. No equal, no endpoint. Union, because you write in two pieces, 9 to positive infinity. Final answer. Any question? Do you understand very well this example? Yes or no? Answer me. Good, Sabrina. And the rest is okay? Okay. Let's move on to the last question of the review package. Okay, by the way, in the test, you don't see system of equation. But by curiosity, I want to solve at least one in your life. Okay, you solve this system. 3x, system of equation is hard. No, it's plain easy. No, Helena, no. Tedious. Well, okay. Depending your your opinion. I respect your opinion. Okay, equal 5. The basic system is 3 equations, 3 linear equations, and 3 unknown, que es x, y, and z. Okay, and this, everything together is considered like a, this is 3, no? Equation 3. Okay, this number I put inside the circle represent the number of the equation. Equation 1, equation 2, equation 3, because it's important. When I want to manipulate the system, linear system of equation. What is my goal? My goal is find x, y, z value que satisfy this equation. So what is the procedure? There are many ways to do that. Not necessarily the only way I make a decision. For example, I select 2 equations. I select the equation 1 and equation 2. Yeah, I copy again. I copy 3x minus y minus z equal 5, equation 1, 2x plus 3y minus c equal minus 16. This is equation 2. So in this moment, I thinking about the strategy for solving this. For example, one possibility, one idea is multiplication the entire equation 2 by negative 1. Negative 1, multiplication the entire equation 2 by negative 1. Why? Because if you multiply by negative 1, at least in the z bar, we have positive z. And positive z and negative z is ready. This is the idea, Ruth. It's ready for elimination. So I multiplication, okay. When I multiply, I have minus 2x, minus 3y, plus z equal 16. And this is my new equation 2, okay, by the way, is perfectly equivalent to the original equation 2. If you want, you forgot this part for a moment, because we are focusing only in the equation 1 and equation 2 new. Okay, now you adding 1 plus 2, 1 plus 2, 1 plus 2 by column, ¿no? Entonces 3 minus 2 es 1x. Negative 1 and negative 3 is negative 4. Negative z and positive z is 0. This is cancel out. At least C is gone. This is 21. Now this new equation I want to call equation 4. Because it's the new equation, but this new equation contains two unknown, x and y. Disappear the c. Okay, now I pairs two equations. Maybe 1 and 3 or 2 and 3. I prefer 2 and 3. Another student can pair in different ways is okay. There are no unique way to solve this. I want to copy now equation 2 and equation 3 here. So 2x plus 3y minus z equal minus 16. This is equation 2, the original equation 2. Equation 3 is x plus 2y plus 4c equal 3. Equation 3. The most important moment is I need to do something. In order to eliminate what? Eliminate the same. Okay, this is the most important idea. If you make a decision, eliminate z in the first couple in the blue bar, you do something in order to eliminate z in the second part. So you eliminate y, not good. Not good because I need to get another equation number 5 that contains only two variables, the same unknown, x and y. So I propose you multiplication by 4, positive 4, the entire equation 2. Because when you multiply 4 times c is 4c. Yeah, I copy down. 8x. What comes from 8? 4 times 2, no? 4 times 3, 12. Y. And 4 times negative c is minus 4c. 4 times negative 16 is negative 64. And this is my new equation 2. I forgot this equation. Not necessarily working anymore with this equation. Okay, now ready to go to adding equation 2 plus equation 3. S9, S14. This cancel out, 0. And this is 61 minus 61. And this is my equation 5. Okay. Now I take equation 4 and equation 5. Yeah, I copy again. This is the last step. X minus 4y, I copy, equal 21, equation 4. And 9x plus 14x, x no y, sorry. Y, look at that. Y equal minus 61, equation 5. Entonces we focus in the linear system of equation. It contains only two unknown in green color, no? Okay, entonces I propose you multiplication maybe the equation 4 by negative 9, because what is my goal? My goal is negative 9 times x is negative 9x. So it's negative 9x. And this is positive 36y. Equal, entonces you multiply, put in the calculator 21 times 9. 21 times 9 is 198, pero negative, of course, no? Negative 189. And this is my new equation 4. And this is history. I don't care anymore. Ready now. Adding equation 5 plus equation 4 by column. This is 0, it's cancel out. This is 50y, 50, yeah. And this is minus 250. Wow, disappear. We have only one variable, easy, divided by 50 both sides. Y is equal to negative 5. I finished. No. The only thing that we are doing is find the y value. I need to find the x value and the z value. Therefore, this is substitution, back substitution, okay? You replace y in the equation and solve for something. Entonces, in this case, I come back at the beginning. No, it's stupid. I come back, for example, to the equation 4 or equation 5, que contain only two variables. I select either, but I suppose que Caesar doing by 4, because then the coefficients are a smaller number, right? So x is I don't know, x is I don't know, minus 4 times negative 5 is equal to 21. Substitution, this negative 5 here, replace. Okay, this is 20. Therefore, x is 21 minus 20 is 1. Super. Okay. Wow, what the hell? The only one que I need to find is the z value. Then entonces I select either equation, the original equation maybe. Okay, contain 3 variables. I select the first one. I suppose I select the first one. And the first one is 3x, pero x I know que es 1. Minus y, que es negative 5. Be careful with the sign. You replace the entire y by negative 5. And you respect this negative here. Minus z, I have no idea who is that, equal 5. Okay? This is 3, this is 5. Minus c equal 5. And it's obvious that this 5 cancels if you want. Therefore, c is 3. Look at c. So 3 minus c, no? 3 minus c equals 0. C is 3. Entonces now, what is the answer? What is the solution? The solution is the triplet order. Triplet order. En alphabetic order, x, y, z is a point in 3D, 3-dimension plane. 3-dimension space, sorry. Entonces x is 1, y is negative 5, and c is 3. End of story. This is the answer. Well, fortunately for you in the test, I don't put any question about this. But in a college algebra, it's important that you see at least one time in your life. Well, you see in high school, maybe, no? Thank you. No, it's okay, it's okay. Because Ruth don't like the system of equations. Entonces, you feel strong to do perfectly the test number 3. Remember, I collect, guys, this is online class, no? Any situation that you have, you need to communicate with me by email, okay? But we have a schedule, and the schedule is that you turn in to me the test 3, March 22nd, no? Is next Monday. See, you cannot, for some reason, coronavirus, I don't know, you inform it, okay? Si you don't inform me, say it's late. And si it's late, maybe I do not accept. Okay? And it's also mandatory the lab online. So you need to remember homework is extra credit. Pretest, no. Pretest have no value. Pretest is only to practice for the test. Okay, let's start with the chapter 4. The chapter 4 is the last chapter. Is very, very interesting because we study now another functions. We study another function que is called transcendental functions. Basically, we study exponential function and logarithmic function. Therefore, it's mandatory that everyone try to bring, not exactly for the next class, but a scientific calculator. So I highly recommend. We don't have to do the test online. Of course you have. Okay. What's going on? Okay, every chapter contains 2 tests. Test number 3 on paper or written, whatever you want to call. Okay, sent to you and online. Yeah, I grade both. 100 points. 100 points. If you don't submit this, 0 point for you. Okay, this is clear. This is no new. Hello. Okay. I say we are using mandatory calculator because we need to compute a special function. What kind of calculator? Scientific, but cheaper, not necessarily expensive. So I recommend TI 30X. It's cheaper. It's only 12 bucks in Walmart and Office Depot. Okay. Well, the first thing we study is the idea for the one-to-one functions and inverse function. Okay, this is the idea today. I don't know if we finish or no, but we start this one. Let me recall something. Let me recall definition for the function quickly, and also the different categories we can find. For example, we have this circle indicates set, a domain, and this circle indicate, or this ellipsis something indicate range. Suppose that we have three values, 1, 2, 3, x1, x2, x3. Remember, domain is the set of the x value in the function in which the function is defined. And suppose in the range we have y1, y2, y3, and you associate in this order. In this direction is obvious. Direction is important. And this is a function I call f. This is a typical 1-to-1 function because one value in the domain is associated with the only one value in the range. They are perfect correspondence. Okay, this is a function. So because function is a special function que es 1-to-1. But this is the only possibility that we have? No. We have another possibility in which, for example, again domain, now again range. Suppose 3.123, suppose 3.123, x1, x2, x3, and y1, y2, y3. Suppose that you associate this and this. You associate this and this. And you associate maybe this and this. And this, nothing. Nobody. This is typical many-to-one. Many-to-one function. And this is possible. There are no violation because the idea, many-to-one. Many-to-one function. This is also function, both are function. Because the definition of the function say that you associate only one. So this is important word, one. What is the violation for the function? Well, the violation is when you have this situation. It's no function. For example, when you associate in this order. For example, x1 associated with the y1, x1 again associated with the y2, x2 associated with y3, and x3 no, nothing. This is typical one-to-many. One-to-many. And one-to-many is a violation because definition of the function say that one relation is a function when only in the range you select only one. In this case, no, you select many. So this is no function. This is a relation, of course, but no function. I suppose that you remember very well this idea. Okay, but what's the goal today? Well, the goal today is inverse function. This idea is classical, and you know very well. Intuitive idea for inverse function. For example, there are several operations que does each other. For example, addition and subtraction are inverse function. Multiplication and division, they are inverse function. A square and a square root, they are inverse function. Because when you apply both together, suppose, hypothetically, suppose one function que es x plus 10, es addition. Entonces you pick one value. You pick one value que es, for example, 5. Plug it in here. Entonces 5 plus 10 es 15. Good. And what is the inverse function? And the inverse function is subtraction. This is the inverse function, subtraction. And subtraction is x minus 10. I suppose it's the same quantity, no? And when you plug it in here, this 15 here, 15 minus 10 is 5. And we come back to the original value, que I select arbitrary. Suppose que I select 5, 5. Suppose que I select 3, 3. Suppose que I select 20, 20. Okay? And this is the idea for the inverse function. Okay, you have intuitive idea. However, we discuss in detail inverse function. The one function is invertible. Invertible means que the inverse function exists. Guys, entonces the notation que we using to call inverse function is something like that. F and minus 1. But this minus 1 is no exponent. No, it's a symbolic way to indicate inverse. So never you consider that this is this. This is completely wrong. This is reciprocal. This is inverse. No. Okay? So this negative 1, que is no exponent, is symbolic way to indicate inverse function. The inverse function exists. So the requirement que the inverse function exists only, look at that, only the inverse function is applied in opposite direction. Look at that, in opposite direction. Opposite direction. This is the inverse, and red color, inverse function. The inverse function exists only if the original function f is 1 to 1. Because basically, the thing that we are doing is the permutation, interchange, domain and range. Entonces, si es 1 to 1, you switching es 1 to 1, no problem. However, si es many to 1, when you interchange domain and range, entonces es 1 to many, and this is no function. Okay, entonces this is no invertible. This is a function. This is a function. Yes, it's a function, but no invertible. Because to be invertible, the original function must be 1 to 1. Otherwise, no. Okay? Do you understand this idea? It's a little bit abstract. Do you understand? Okay. Do you understand? Yes or no? Answer me. Okay. Okay, good. Now, let me take advantage this moment to say que, for example, domain of the original function f is equal the range of its inverse. Because it's easy. The only thing you are doing is interchange domain and range. And the range of the original function is equal the domain of its inverse. Keep in mind this important relationship between these. Entonces, in one easy way to understand, the thing that we are doing, guys, is interchange x and y, like that. Interchange x and y. You want to find the inverse function, you interchange x and y. I bring some example to this. But first of all, how do you know? What are the tests can help me to determine if the one function is one-to-one or not. One-to-one or not. Because if it's not one-to-one, I know, professor, this function is not invertible. Okay? However, see if it's one-to-one, yes, it's possible. The inverted function, the inverse function. Okay, entonces I recall something. Recall the vertical line test. Vertical line test. The vertical line test is a test, super important test, que allow us. Can you slide up the little bit? Yeah. It's okay. Okay, I try to explain something. Okay, what is my goal now? My goal is try to investigate one tool can help me to determine if one function is one-to-one or not. So I want to just recall, refresh your memory, the vertical line test. The vertical line test is a test. For example, you have a function. Suppose you have a function. Suppose. Que when you apply the vertical line test like that, if the hypothetical vertical line crosses the curve and only one point, is a function. Yes, pass the test. If it crosses 2 points, no. But this test allow me discover if the graph in red color is a function or not. Okay, but I want to discussing now the horizontal line test. Horizontal line test. There's a more sophisticated test that allows us to determine if the graph of the function is one-to-one or no. Okay, let me try to see 2 examples. For example, this graph. Well, no this. This graph. You apply hypothetical horizontal line. Si crossing 1 point, yes, it's one-to-one. This case cross in 2 points, no one-to-one. Okay, so any example that we are doing so far, you investigate. So the step 1, the step 0 is investigate if the function is one-to-one. How? Well, apply the horizontal line test. You apply. See the horizontal line test failed, the answer is no. Bueno, professor, entonces this function is no invertible, no inverse function. And we can now do continue. See, the answer is yes. We have inverse. Entonces you continue, find the inverse. Another thing I want to explain in the example now. Do you understand very well the horizontal line test? Okay, let's move on to the one couple of the example to illustrate very well the yes, okay. Example 1 to understand everything. Example 1 is one function like that, f of x equal x cubic plus 3. What they want? Well, they want several steps. Step 1 is determine if this function is one-to-one. Well, the only test I have to determine this is the horizontal line test, no? Y I need to know in color algebra que the graph of this function is a family. So I suppose the graph of the cubic function alone, look like that. Okay, no, not good. Approximately. A typical odd function. Look like that. This is x, this is y, this is x cubic. And plus 3, the only thing that we are doing plus 3 is the vertical shift 2 units up. So the difference is that this graph is similar, very similar to this. The only difference is that it's moving 3 units up. Okay, this is the graph that corresponds with the x cubed plus 3. Everyone follow me or no? It's a typical vertical shift 3 units up. And what do you think about the horizontal line test? Pass the test or fail the test? Well, I have no idea. I try to do hypothetical horizontal line. Choop. 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 Only crossing in one point the blue curve. Therefore, it is 1-to-1. Then it is 1-to-1. Therefore, the function gets given in the example 1 is invertible. And let's move on to the second step, que is find the inverse function equation. Okay, everyone understand the step 1? It's clear? In this example, no? Good. Second example is clear, okay. Que is find the equation for the inverse. Entonces es easy because I take the original. Look, the original is f of x equal x cubed plus 3, you know? And you immediately replace f of x for y because you know very well that f of x and y is the same thing. But this is countable sometimes, the function notation to understand, no? Transformation, reflection, blah, 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 blah. But it's the same stupid thing. Therefore, in order to find the equation for inverse, the most important idea is you interchange x and y. Guys, this is the key idea. Then you copy now x here, y cubic plus 3. Wow! And that's it, almost. That's it. This is the inverse function. But the only problem is expressed in implicit form. What means implicit form? Implicit form means that y is not isolated. Y is not isolated. This is not clear. It's confusing. Now you express it now in explicit form. Explicit is clear. Explicit form. How? So for y, you subtracting 3. Apply cubic root both sides because I want to eliminate the cubic power. That's the cubic root of x minus 3 is equal y. And this is my new y. And by the way, my new y is the inverse function. Okay, so my conclusion of the topic number 2 is find the inverse function equation is, the inverse function is cubic root x minus 3. And make sense of this or not? Okay, remember the idea of the inverse function is try to do opposite operation, like addition, subtraction, multiplication, division. In this case, the operation that we are doing in the original is addition 3 and cubic power. In this case, subtracting 3 and cubic root. So maybe it's logical, no? que es the inverse operation. Just in case, to understand much better, no intuitive ideas, you know, actually, accuracy idea. Let's do in the step 3, que the step 3 is a check. Check what? Check that equation. How you checking this equation? Well, okay. To check in this equation, I propose one idea. You are doing the composition F inverse. In different order. We are doing in this order. Remember, the ordering is important in the composition, or in this order, F inverse composition F. And the answer in both cases should be identity function. A similar idea que we discussed before. Remember the example que es x plus 10 and x minus 10, no? So you put each other together, the 10 is cancelled and you get identity function. So we come back to the original. But I want to prove in general for any expression. Suppose that we are doing the composition of the function in this order. What means that? That means that you take, for example, the first function gets inverse, this one, gets this expression, and you substitution where? Here, in the x place. Entonces f composition f inversa is equal. Open the parenthesis to understand this. I copy cubic root x minus 3. And this is raised to the cubic power, get this 3. This 3 is cubic power plus 3. Do you understand what are you doing? I put the inverse, I put inverse function, totally the inverse function inside the original function. Let's see what happened. Well, the cubic power and the cubic root is cancelled and stay x minus 3 plus 3. Wow. And 3 minus 3 is 0, identity function. Super. I proved that. Look. Let's do it in opposite direction, in different order. In different order is, you take now the original and substitution where? Here. Okay, now I try to find f inverse first, f inverse second, sorry, and f first. Entonces es cubic root. Entonces no x anymore, es x cubic plus 3 minus 3. Okay, this minus 3 is this minus 3, no? Minus 3. This is cancelled. And stay alive. Cubic root x cubic. Again is x. Super. I prove that part. Everyone follow me? Confusion or clear? Clear. Okay. Now let's move on to the fourth part. Fourth part is domain. Domain of the original. Domain of the inverse. Range of the original. And range of the inverse. So determine 4 sets. 1, 2, 3, and 4 sets. Well, what do you think about domain of the original? This is the original. Remember, in Euclid algebra, when I ask you find the domain, the supposition is the domain is all real number except the restrictions. And restrictions we have only when you have division, you know, get the bottom part not 0, illegal. Number 1 restriction. Number 2 restriction is when you have a square root. Get the expression inside the square root must be non-negative. And number 3 is when you have a combination both, que is P divided by Q. By Q, no. By radical E. We have the combination, que is the expression inside the radical must be positive. And we have another possibility, they are combinations. But in this case, we have no division, we have no square root. Therefore, the domain is obvious, it's all real number. Okay? Domain of the original. And what about domain of the new expression, the inverse? It's cubic root. Yeah, I remember something. Look, I remember the square root, we have problem with the square root. Look at that. Because the graph of the square root look like that. Look, this is the graph of the square root. We have no negative part. Because the square root negative number is imaginary, no? Imaginary do not exist in the real field. However, what happened with the cubic root? Different situation happened with the cubic root. In the cubic root, the graph is different. It's like that. It's similar to that part, and that part is always positive. This is cubic root. Why is accept negative? Because, for example, cubic root, negative 27. Negative 3 times negative 3 times negative 3 and negative 20. Square root negative 25. No, it's not real. That is the reason that we have no parabola in that part. Conclusion, the domain of this is also a real number. Okay, and what about range? Well, the range is easy because I know that the domain of the inverse, sorry, this is equal to this. Yeah, just copy. Okay, and this is equal to that. I just copy. Good? Everyone follow me? Everyone understand very well the idea? I finished, no? I have 5 steps. It's too long problem. Okay, let me try to explain one fantastic way to do the graph of the function and its inverse simultaneously. Look. I know. I can do in decimals, of course. But okay, let's do it by hand. Suppose the graph of the original is something like that. Okay, the original was, okay, the function original was x cubed plus 3, no? So we have in 3, 1, 2, 3, one famous point, que es the point 0,3. And for example, let me try to evaluate in 0, in 1, and in negative 1. Let me make a zoom to see more clear. And 1 is obvious que 4. That point is the point 1,4. Because 1 here, 1 cubed is 1, plus 3 is 4. And negative 1 is 2. At that point is the point negative 1,2. And our graph look like that. More accurate, no, more clear. You know, this arrow indicates it is continuous forever, similar to this. Okay, now suppose I want to do the graph of the inverse. Inverse was cubic root x minus 3, no? Let me see the verification. Yes, that's the inverse function. We can do using this basic function and apply transformation. But no. Let's do it in one fantastic way. Because you know that the idea behind the inverse function is interchange x and y. Therefore, the only thing you should do is this point, is 0,3, and the inverse function should be 3,0. 2, 3, 3,0. Only interchange x and y. This point, que is the point 1,4, and inverse would be 4,1. 4,1. And this point is negative 1,2 should be 2,1. 2, negative 1. And our inverse look like approximately like that. Like that. And you can see that both graphs, this is the original f of x, and this is the inverse, are symmetric with respect the line, y equal x, que represent the identity function. Okay, so this is fantastic because you have the graph of the original. The only thing you should do in order to find the graph of the inverse is interchange x and y. Just in case, let me verification, see we are doing well or no. Okay, look. Remember, this is the cubic root function. According to this transformation, the only thing we are doing is horizontal shift 3 units in what direction? To the right, because it's negative. Okay, so the only difference exists between this curve and this curve was I'm moving point by point 3 units up. At this point, moving 1, 2, 3. This point moving 1, 2, 3. This point moving 1, 2, 3, and we get that. Okay, guys, the time is over now. Okay, don't forget. March 22nd is do the both tests, online and on paper. On paper you send me by email, online no. Online you only submit in Alex. Okay, clear? Super clear or confusing? Thank you, appreciate so much. Okay, okay, always we are doing a review. Bye, guys. And don't change anymore this background, which I don't like.